Imagine a world where we can predict how fluids behave without ever spilling a drop. This is the magic of computational fluid dynamics, or CFD for short. It's like having a crystal ball for engineers and scientists. CFD uses powerful computers to solve complex equations. These equations describe how fluids move and interact with their surroundings. In the past, engineers had to build physical models to test their designs. This was expensive and time-consuming. Now, with CFD, we can create virtual models in a fraction of the time. We can test hundreds of designs without ever leaving our desks. It's like having a laboratory inside a computer. CFD isn't just faster and cheaper, it's also more detailed. We can look at things we could never see in real life. We can peek inside engines as they run. We can watch blood flow through arteries. We can even simulate the weather patterns of distant planets. CFD opens up a universe of possibilities. But with great power comes great responsibility. CFD simulations are only as good as the people who create them. That's where experts like ANSYS CFD come in. They have the knowledge and experience to turn raw data into valuable insights. They can help unlock the true power of CFD for any project, big or small. Enter Mr. CFD, a team of wizards in the world of fluid dynamics. They're not just number crunchers, they're problem solvers. Mr. CFD offers a range of services to help engineers and companies tackle their toughest challenges. Think of them as your personal CFD gurus, ready to guide you through the complexities of fluid simulation. One of Mr. CFD's key services is consultation. They sit down with clients to understand their unique problems. They ask the right questions and dig deep into the details. This isn't just about running simulations, it's about finding the best approach to solve real-world issues. Mr. CFD's experts can suggest the most effective methods and tools for each project. Training is another crucial service offered by Mr. CFD. They believe in empowering their clients. Through workshops and courses, they share their knowledge of CFD techniques and software. It's like teaching someone to fish rather than just giving them fish. Clients learn how to set up simulations, interpret results, and make informed decisions based on CFD data. Of course, Mr. CFD's bread and butter is CFD simulation itself. They use state-of-the-art software and powerful computers to model fluid behavior. Whether it's air flowing over a car, water rushing through a pipe, or blood pumping through a heart, Mr. CFD can simulate it. They handle everything from simple two-dimensional models to complex three-dimensional simulations with multiple physics interactions. Now let's dive into something really exciting. Fluid structure interaction, or FSI. This is where things get interesting. FSI is like a dance between fluids and solid objects. It's not just about how fluids move, it's about how they push, pull, and deform the things around them, and in turn how those objects affect the fluid. Think about a flag waving in the wind. The air moves the flag, but the flag's movement also changes how the air flows. Or consider a fish swimming through water. The fish's body moves the water, but the water's resistance shapes the fish's motion. These are examples of FSI in action. It's a two-way street of forces and reactions. Understanding FSI is crucial in many fields of engineering. In aerospace, it helps design wings that won't break in strong winds. In civil engineering, it's used to build bridges that can withstand rushing water. In biomedical engineering, FSI simulations can show how blood flow affects heart valves. It's a powerful tool for creating safer, more efficient designs. But FSI simulations are tricky. They involve complex math and require lots of computing power. That's where experts like Mr. CFD come in. They have the knowledge and tools to handle these challenging simulations. With their help, engineers can unlock insights that were once impossible to obtain. FSI opens up a whole new world of design possibilities. Section 4. ANSYS Fluent, the tool of choice for complex problems. When it comes to CFD software, ANSYS Fluent is the heavyweight champion. It's like the Swiss Army knife of fluid simulation tools. Mr. CFD has mastered this powerful software, using it to tackle even the most complex engineering challenges. Fluent is more than just a program. It's a gateway to understanding the invisible world of fluid dynamics. ANSYS Fluent can handle a wide range of fluid flow problems, from incompressible to highly compressible flows, from laminar to turbulent regimes. Fluent does it all. It can model heat transfer, chemical reactions, and multi-phase flows. Think of it as a virtual laboratory where you can test almost any fluid scenario imaginable. And Mr. CFD knows how to make the most of this versatile tool. One of Fluent's strengths is its ability to handle complex geometries. This is crucial for real-world engineering problems. Fluent can mesh irregular shapes and adapt the mesh as the simulation progresses. This means more accurate results, especially in areas with rapid changes in fluid behavior. Mr. CFD's experts know how to set up these advanced meshes for optimal performance, but Fluent's power goes beyond just fluid dynamics. It can also couple with other physics simulations. This is where FSI comes into play. Fluent can work with structural analysis tools to model how fluids and solids interact. Mr. CFD leverages this capability to provide comprehensive solutions. From airflow over aircraft wings to blood flow through artificial hearts, Fluent in the hands of Mr. CFD can simulate it all. Section 5. Real-world applications from aerospace to biomedical. The applications of CFD and FSI are as vast as the imagination of engineers. In the aerospace industry, these tools are indispensable. Imagine designing a new aircraft. CFD can simulate how air flows over the wings and fuselage. FSI can show how this airflow affects the structure of the plane. This helps engineers create more efficient, safer aircraft. Mr. CFD has worked on projects to optimize wing designs and reduce drag on aircraft bodies. In the automotive world, CFD and FSI are driving innovation. They're used to improve fuel efficiency by reducing air resistance. They help design better cooling systems for engines. FSI simulations can even model how a car's body deforms in a crash. Mr. CFD has helped car manufacturers optimize everything from side mirrors to entire vehicle shapes. Their work contributes to cars that are faster, safer, and more fuel efficient. Biomedical engineering is another field where CFD and FSI shine. These tools can simulate blood flow through arteries and artificial heart valves. They can model how drugs disperse through the body. FSI is particularly important in designing medical devices like stents or artificial organs. Mr. CFD has been involved in projects to optimize the design of artificial heart valves and simulate blood flow in aneurysms. Even in fields like environmental engineering, CFD and FSI play crucial roles. They can model the spread of pollutants in the air or water. They can simulate the effects of wind on the buildings or the impact of waves on offshore structures. Mr. CFD has worked on projects to optimize wind turbine designs and improve the efficiency of water treatment plants. The possibilities are endless, and Mr. CFD is at the forefront of exploring them. Section 6. Success Stories, Mr. CFD in Action. Let's look at some real examples of Mr. CFD's work. One project involved optimizing the design of a wind turbine blade. The client wanted to increase energy output without compromising structural integrity. Mr. CFD used ANSYS Fluent to simulate airflow around different blade designs. They coupled this with structural analysis to ensure the blades could withstand the forces involved. The result? A new blade design that increased energy output by 15% while maintaining safety standards. In another case, Mr. CFD helped a biomedical company develop a new artificial heart valve. The challenge was to create a valve that minimized blood clot formation. Using FSI simulations, Mr. CFD modeled how the valve leaflets moved in response to blood flow. They identified areas of stagnant flow where clots might form. This led to design changes that significantly reduced the risk of clotting. The company was able to move forward with clinical trials much faster than expected. Mr. CFD also tackled a complex problem in the automotive industry. A car manufacturer was experiencing unexpected vibrations in their vehicle's side mirrors at high speeds. Using CFD and FSI, Mr. CFD simulated the airflow around the mirrors and its effect on the mirror structure. They discovered that vortices were forming behind the mirrors, causing resonance. With this insight, they helped redesign the mirrors to eliminate the vibration problem. These success stories showcase Mr. CFD's ability to solve real-world problems across various industries. Their expertise in CFD and FSI, combined with their mastery of tools like ANSYS Fluent, allows them to tackle complex engineering challenges. From improving renewable energy technology to advancing medical devices and enhancing automotive design, Mr. CFD's work has far-reaching impacts. They're not just running simulations, they're helping to shape the future of engineering.